Here are some problems to find derivatives. Let's do them one at a time. The function is sine inverse of root x. Here the most outside function is sine x. Remember the derivative of sine inverse x is 1 by square root of 1 minus x square. Here inside function is root x. So when you find the derivative of this 1 by square root of 1 minus, here it will be square of root x, okay, times, because there is an infinite function, because of the chain rule, derivative of root x has to be done. 1 by square root of 1 minus root x square is just x, times derivative of root x is 1 by 2 root x. So you can write this answer as 1 by root x times 1 minus x. Let's work on part B. The function is natural log of sine x. Again, there is an outside function and there is a inside function. We know that derivative of natural log of x is 1 by x provided x is non-zero. So here function's derivative would be 1 by, because inside there is sine x, 1 by sine x times the derivative of sine x. We know that the derivative of sine x is cosine x. Therefore, this will be 1 by sine x times cosine x is equal to cotangent x. So the answer is cotangent x, because cosine x by sine x is cotangent x. Part C. The function is 2x squared plus 3x times dx. This is product of two functions. We know the product of two functions, if y is u, v, the derivative is first function's derivative times second as is, plus first function times derivative of second. So derivative of the first function is 4x plus 3 using the power rule times second function as is, plus the first function as is times the derivative of ex is just ex, if you guys remember the formula. Now we know that ex is common between both the terms, so it can be factored out. We'll be left with 4x plus 3 plus 2x squared plus 3x. These two terms are like terms, so we can add them. 2x squared plus 7x plus 3. Let's work on part D. Y is natural log of arc tan of t4. Y is a function of t. So when you find dy by dx, the first formula we need to use is derivative of natural log of x is 1 by x. Here the variable is t, so write dy by dt. And inside function is arctan, so 1 by arctan of t4 times the derivative of arctan t4. Derivative of arctan or tan inverse x is 1 by 1 plus x squared. That's the formula. So here arctan is times the derivative of this is 1 by 1 plus what is inside? T4. So T4 square times the derivative of T4, because inside still there is a function, right? And that can be done using power rule. So we have our answer arctan T4 here in the denominator times 1 by 1 plus t the power 8 times 4t cube. You can collect it all together to write it nice and compiled. Let's work on part E. Y is e the power x square minus x. We know the formula, derivative of e the power x is just e the power x. But here in the numerator, in the exponent, we have x square minus x. So when we find the derivative, it will be e the power x square minus x, but we need to derivate that using chain rule. E the power x square minus x times the derivative of this is 2x minus 1, and that is your answer to the derivative of part E. F of x is natural log of x square plus 3x plus 5. Remember, the derivative of natural log of x is 1 by x. Therefore, derivative here would be 1 by whatever is inside, right? X square plus 3x plus 5 times the derivative of inside. The denominator stays as is because we already write that. Derivative of this is 2x plus 3. So the answer is 2x plus 3 divided by x square plus 3x plus 5. Last part, y is equal to e to the power t sine 2t. Derivative, the variable with respect to t. We know the formula, the derivative of e to the power x is just e to the power x. Therefore, this will be just the same. But the problem is the exponent is not just t. So we need to differentiate that also using chain rule. E to the power t sine 2t times, because we need to differentiate this has product of two functions. Derivative of t is 1 times sine 2t plus t as is. The derivative of sine is cosine 2t times 2. The answer is sine 2t plus 2t cosine 2t.